Hello and welcome to this screencast about modeling and right triangles with sine or cosine. Previously we used the sine and cosine functions to find missing sides of right triangles. In this video we will do the same, but we will do that to model a real world situation. So suppose you are parasailing behind a boat. A 700-foot line connects you to the back of the boat, which is at a 31-degree angle of depression below you. Assume there is no slack in the string. We want to determine how high above the boat you are and what is the horizontal distance between you and the boat. So take a moment to draw the triangle that you think represents this situation and label the known quantities. Okay, so if we have our person here connected to the boat, we can draw this right triangle. And we know that this is a 700-foot line connecting you to the back of the boat. And we're told that the angle of depression is 31 degrees. So here it's important to note that the angle of depression is the angle between a horizontal line of sight. So if you're here, we have a horizontal line of sight and the line of sight to the object. So our angle of depression is this angle inside here, and that's 31 degrees. And if you remember from geometry, when we have parallel lines, which these two horizontal lines are parallel, then these alternating angles are equal. So we can conclude that the angle here that I labeled is also 31 degrees. So if we want to determine how high above the boat you are, let's call that H. And then we want to know what the horizontal distance is between you and the boat. Let's go ahead and call that D. All right, so take another moment and see if you can use the sine and cosine functions to find your height above the boat and your horizontal distance between you and the boat. Okay. So we noticed that the side representing your height above the boat is opposite the 31-degree angle. So that means we're going to use the sine function. The sine of 31 degrees will equal the opposite side, which we called h in this case, divided by the hypotenuse, which is 700. And if we multiply both sides by 700, then h, your height above the boat, is going to equal 700 times the sine of 31 degrees. This is your exact answer, and it would be measured in feet. And then if you want to use a computing device, you would need to make sure that it is in degree mode, and you would get an answer of approximately 360.53 feet. You should really take the time to verify that you can get that. If you're getting a negative answer, you may want to verify that you are not in radian mode and instead in degree mode. All right, so now our last question here was the horizontal distance between you and the boat. So you'll notice that the leg representing your horizontal distance is adjacent to the 31-degree angle, so we'll use the cosine function. The cosine of 31 degrees equals the adjacent side, which we've labeled D, divided by the hypotenuse, which is 700. So again, we'll multiply both sides by 700. And so your horizontal distance from the boat is 700 times the cosine of 31 degrees. And that would be in feet. All right, we're measuring a distance. That would be your exact answer. And then using a computational device that is in degree mode, you would find that your distance horizontally from the boat is about 600 feet, just over 600 feet. All right, so I hope that has helped you visualize how we can use the sine and cosine functions to model some real-world phenomena.